வணக்கம் நண்பர்களே, மீண்டும் ஒரு வீடியோ சந்திப்பதில் மகிழ்ச்சி. ஸோ இன்னைக்கு கிளாஸில் we discuss about important topic then Faraday law of electromagnetic induction. So then Faraday's law of electromagnetic induction. So how to define? So the magnetic flux. So then magnetic flux, then pi, that is flux can be write it as B A cos theta. Okay, here where B is magnetic field, so unit is Tesla. Next A என்றது area, so area க்கு unit meter square. Theta angle between B and area vector. Then unit of flux is most important. The unit of flux is Weber, most important. Okay, so this is the definition. You have to understand the magnetic flux. அப்போ magnetic flux எப்படி எழுதலாம்? Then pi is equal to BA cos theta. From that B is magnetic field, then unit is Tesla. Then A is the area, unit meter square. Then theta is the angle between B and area vector. So then unit of flux is Weber. Okay, so next we define Faraday law. Okay, then Faraday's law. Okay, so magnetic flux என்னன்னு தெரிஞ்சாதான் then we have to understand the Faraday law. Okay, there should be two cases. One is induced EMF, that is single turn. Then another one is a n number of turns. Okay, then we have to write both the formulas. Okay, so then Faraday's law, first one induced EMF, that is important. Induced EMF only single turn. So single turn, then induced EMF is equal to then minus D, there should be a magnetic flux divided by then dt. Okay, then second one induced EMF n turns, that can be write it as then E is equal to, we have to put minus n, then d flux by dt. Okay, so here a negative sign, so the negative sign indicates, that is called as Lenz law. So in exam point of view you can know all the point. Okay, so then magnetic flux na enna theriyano. Then after that, then Faraday law two cases. One is induced EMF with respect to single turn, then another one is a number of turns. So in that induced EMF, the negative sign indicate, that is called as Lenz law. Okay, good. Okay, so next is an average induced EMF. So this is important because while doing the problem those cases are important. Okay, then average induced EMF for numerical uses only. Okay, sometimes problem ketangana, then we have to use this formula. Okay, then average EMF, which is equal to then minus n then del pi by del t, that is flux. Okay, so this is the most important for numerical cases only. Okay, Okay, next is some of the special cases. Okay, so then special cases, one is rotating coil, that is AC generator. Then magnetic flux pi can be written as BA cos omega t. Then induced EMF is equal to NA, then B omega sin omega t. Okay, அப்போ maximum EMF, so இதெல்லாம் ப்ராப்ளம் போடும்போது you can understand. Okay, then induced EMF, maximum induced EMF which is equal to NB A omega. So this is most important. Okay, இது நிறைய டைம் கேட்டிருக்காங்க. Okay, so then magnitude maximum induced EMF is NBA omega. Okay, so the next one case, there should be two special cases. One is rotating coil, then another one is state conductor moving in magnetic field, that is equal to then B LV. Here L is the length of the conductor, then V is the velocity of motion. Okay, so next is self and mutual inductance. There should be two cases, then we discuss in the next classes. Today we discuss about only the Faraday law and what are all the important points. So the Lenz law already solid, the negative sign indicate that is called Lenz law. There should be a direction rule. So the induced current always oppose the causes to produce it. Okay, that it ensure that energy is conservation. Okay, so I have to write Lenz law also. Okay, sometimes there should be acts. Okay, so the Lenz law, so Lenz law is a direction rule. Okay, so first point, then induced current always oppose the cause producing it, that is it ensure energy conservation. Okay, so these are all the important point you have to remember. Then another one is a Fleming right hand rule for generator rule. There should be a two rule. One is, so another one also I have to write it. Okay, so next one is Fleming right hand rule for generator rule, that is then thumb, you know very well, then thumb for motion of conductor and forefinger stands for magnetic field and middle finger stands for induction current, induced current or induced current. Okay, so these are all the point you have to remember. Okay, so I have to recall once again. So then Faraday law of electromagnetic induction la, then we know first magnetic flux, this is the formula. Next Faraday law la, then induced EMF, there should be two cases, one is single turns and number of turns, then average induced EMF for numerical uses, then two special cases, one is rotating coil, then another one is a state conductor moving in magnetic field. Then there should be two rules, one is direction rule and generator rule, then direction rule for Lenz law and generator rule for Fleming right hand rule. Okay, so these are all the point you have to remember for those topics. Okay, that is Faraday law of electromagnetic induction. Okay, next is some of the important point we have to discuss related to the exam point. Okay, so then important units, so most important, so then important units, so then first one magnetic flux. Magnetic flux symbol can be write like this. Okay, so this is the symbol, then unit, then magnetic flux unit Weber. Then second magnetic field, then symbol B, that is Tesla. Okay, T. Then third, then induced EMF, the symbol represented as E, unit is volt, V. Then fourth, time, that is symbol for T, then unit is second, symbol S. Okay, so next important point you have to remember, that is fifth point, if there is no flux changes, if there is no flux na appo enna agum, there is no EMF. So idella accession and recession la kekkalam. Okay, then faster change we get larger EMF. Then seventh point, then EMF depends on rate only. Okay, not magnitude of flux, not magnitude of flux. Then generator works on Faraday law plus Fleming rule. Okay, so these are all the point you have to remember. The last 5 to 8 point is most important. Okay, those points are depends upon the accession and reasoning. Okay, so next one of the important problem we discuss. Okay, so already we know the formula. Okay, so this is the problem. The magnetic flux linked with a coil changes from 0.8 Weber to 0.2 Weber in 0.2 seconds. So how to solve this? So we have to first find the induced EMF. So என்ன கண்டுபிடிக்க போறோம், induced EMF தான். So அப்போ what is the formula for induced EMF? Then induced EMF, that is E is equal to del pi by, that is flux by T. அப்போ given, so then given, then del pi, that is 0.8, 0.822 minus 0.2, அப்போ we have to get 0.6 Weber. So next time, then del T is equal to 0.2 second. அப்போ we know the formula. So just we have to substitute, then to calculate, then calculating, then is equal to what is the del pi, that is 0.6, 0.6, then time is 0.2. Then we have to get what is the answer, that should be a 3 volt, that is the exact answer. Okay, then we have to get this one. Okay, this is the answer. Okay, so if you get 0.3, then we have to divide 10, then 3 volt. Okay, so this type of problem can asking repeatedly in the previous exams. Okay, so these are all the point you have to remember for studying this topic. Okay, so then remaining problem for this topic we discuss in next classes. Okay, thank you.